How do I pass an array to a method? How do I return an array from a method? Do I even need to return an array from a method? This is Maggie from Design Code Debug Repeat. Welcome to the channel. If you're here because you want to learn to program in Java, you're in the right place. This is the 42nd video in the Introductory Programming in Java full course, and the third video of the final lesson, Lesson 7, Arrays and ArrayLists in Java. So far, we've looked at arrays and reading into an array from a file. Today, we're going to look at how and when we might pass an array to a method or return an array from a method. Let's get right into it. What I have here is a new version of our program from the last video that reads integer values from a file and stores them in an array. Instead of processing the array in the main method, I've written some static helper methods to work with the array. Let's look at the main method first. Here we declare an array variable with int, open close square bracket, value array. Remember that a data type followed by square brackets means an array that holds values of that data type. This variable declaration doesn't create an array. It is simply telling the Java interpreter that the variable value array will reference an array of integers. On line 70, I then set that array reference equal to whatever is returned from the readFile method. After that, if the variable is not null, we send it to the printArray method, then the erase_array method, and then the printArray method again. You can see that these methods do not return anything. If I run the program, you can see it prints some values. You can see from the file, which I have open on the right, that these are the first 50 values of the file. And then it prints 50 zeros. The values from the file are the result of our first call to printArray after reading the values from the file. And the zeros are the result of our second call to printArray after calling erase_array. Let's look at the syntax of passing arrays as parameters and returning arrays, and then talk about when we should return an array from a method and when we don't have to return an array from a method. We'll begin with the readFile method, and we're going to focus on the mechanics of returning an array from a method. We're not going to talk about the code to read from the file into an array. You can watch the prior video if you want to learn about that. I'll put a link here. Let's start with the method header. Remember, we have the access modifier public followed by the keyword static, as this program is entirely static, part of the class. This is not a class that is meant to be instantiated as an object. And then we have the return type. We are returning an array from this method, so we specify an array data type. Remember, that is a data type followed by square brackets. So for our integer array, that is int, open close square bracket. As weird as that syntax might look, it's just the syntax for an array data type, and we always put the return data type after the modifiers. So there's nothing new here except the array data type. The other interesting thing about the header is the throws clause. We're now creating a scanner by passing a file reference here in the readFile method, so we must put the throws clause here. Remember, the scanner constructor will throw a file not found exception if the file isn't found, and at this time, we're just going to keep throwing that exception until the Java runtime environment handles it. So we must put the throws clause here. But I want you to note we're also putting it in main. We must. I want to take a moment to explain that. When an exception is raised or thrown, it is either handled or it is thrown up the call stack. We have the Java runtime environment invoking main, so that's the first frame on our call stack. And then main invokes readFile. That's the second frame on our call stack. ReadFile invokes the scanner constructor, so that will be the third frame on our call stack. Without going into the details of how that works, we simply know the scanner constructor can throw an exception. That means that in each frame on the call stack moving backwards, we either need to handle the exception, in which case the buck stops at that frame, or we need to throw it. Since we're never going to handle it, the method for each frame on the call stack in this chain must throw the exception. If I write more methods in this program and one of them calls readFile, then that method must also throw the exception. Any method that calls a method that throws an exception must either handle the exception or it must also throw it. in our program, the exception will finally be handled by the Java runtime environment by inelegantly crashing our program with a red error message. That's okay. We'll learn how to handle exceptions in the intermediate videos. Okay, now this method is going to create an array and return it. This method has its own array variable, and then this method must somewhere have code with the new keyword that creates the array, and then it will have a return statement that returns the array. You can see on line 20, we declare the array and initialize it to null. More on that in a moment. And then on line 26, we have the code value array equals new int max size, which creates the array. And on line 39, we have return value array. If we're returning an array from a method, that array must be created with the new keyword in the method. If it's not created with the new keyword in the method, it has to be created with the new keyword somewhere. Maybe the method calls another method that creates it, or maybe it actually comes into the method as a parameter and is already created. Because there could be an error with the file, I'm initializing the variable to null, and therefore returning null if the array was never created. Another option is to create a completely empty array. What's important is that it's clearly documented what this method will return if the file can't be read, so the calling method knows to check for that error condition. We'll do this differently once we learn about exception handling, but we'll still have to decide how to respond to the error state and document that. Now, back where we're invoking this method, we're assigning the result of the method to the variable value array. Note that is declared as type int, open close square bracket, the same as the return type of the method. We don't want to create that array here in main. Suppose we had the code value array equals new int max values, creating an array. And then we have the code value array equals read file num countries legal.txt max values. You might think the array we just created here in main would be filled from the file, but that is not what would happen. If we create an array here in main, that array will be created in heap memory, and our reference value array on the call stack would reference that heap array. Then we invoke read file. This method has its own variable called value array. Assuming the file exists on line 26, we have the code value array equals new int max size, which creates another array in the heap. This one is being referenced by the value array in read file. That gets filled in the loop. Then, on line 39, we return value array. So we're returning the reference to this new array in the heap. And back in main, that gets assigned to value array in main. Now value array in main points to the new array. What happens to the array it was previously pointing to? If there are no other references to it, and there are none in this program, it will get marked for garbage collection, and so eventually that memory will be reclaimed. It's not a disaster in Java, but it's memory that never should have been allocated because it's never used and is immediately discarded. Now, if the file was bad, and so read file returned null, value array in main would now reference null rather than the array that had been allocated in main, and again that memory would be marked for garbage collection. Now let's look at print array. This one is hopefully simpler. In main, we're invoking print array, and we're passing in our reference to value array. Let's look at print array's header. Public static void print array. So this method does not return anything. And then the parameter int open close square bracket array. So we are passing in a reference to an array of integers. Again, int open close square bracket is the data type for an array of integers. Importantly, we don't know what size this array is. It could be an array of any size. All we know is that it is an array of integers. And print array then simply prints the array. It uses a for loop to iterate over the array, using I less than array.length as the stop condition of the loop, so it will never read past the end of the array, and it then prints array sub I. Now, this method does assume the array exists because it's indexing into the array and it's accessing the array.length field. If we pass null to this method, we would get a runtime exception. There's nothing really new here except getting used to the int open close square bracket being the data type array of integer, and understanding that we don't know the size of array being passed to this method, but the array always knows its own size with the length field. Now, finally, erase array is very similar to print array. In main, I'm calling erase_array and passing in our array value array. And you can see the header of erase_array is identical to the header of print_array, except for the name of the method. So why do I even have this method as an example? The erase_array method sets each element of the parameter array to 0. What is important here is that the original array is changed. We don't need to return the array because an array is an object, so a reference to value array from main is passed to erase_array. It is therefore pointing to the same array in heap memory, and anything it does to the array will be a change to the original array. If we didn't want the array to be changed, this would be referred to as a side effect. A side effect is when a method does something in addition to its original purpose, either intentionally or unintentionally. It's important to understand that if you pass an array to a method, you are passing a reference to your data, and the method could potentially modify that data. If you don't want your array to be changed, you need to copy the array and then pass the copy to the method. That way the method can operate on the copy and your original array is untouched. Let's make a copy of our value array in main and then pass the copy to erase_array and see what happens when we print after the erase_array method. First, I want to tell you how you don't make a copy, because this is an easy mistake to make. I'm going to declare a variable right here after print array called int open close square bracket copy. Now I have a variable reference to an array of integer, but it's just a declaration. It's not pointing to anything yet. Suppose I wrote copy equals value array. That's how you copy a primitive variable. However, arrays are objects. This does not copy value array. It copies the reference to value array, exactly the same as when we pass an array as a parameter. We now have a second variable pointing to our original array. Anything I do to copy will be done to value array, because these references are both pointing to the same array in the heap. Do not copy an array this way. You're not copying the array, just the reference. Now, there are several ways to copy an array, but it's important that you know how to do it manually, with a loop. This is because there will be many situations in which you won't be able to use a shortcut. I'll show you one of the shortcuts after we copy the array with a loop. I'm going to delete the line of code that is the bad copy, and after int copy, I'm going to write equals new int value array.length. I'm passing in the length of value array to the constructor because I want this new array to be an exact copy of value array. Therefore, it should be the same length. And then I'm going to use a loop, and I will loop over value array and assign each value to the corresponding value in copy. So for int I equals 0, I less than value array.length I plus plus, and then copy sub I equals value array sub I. It's as simple as that. The element at index I in value array will be copied to index I in copy. And now I'll pass copy to erase_array instead of value array. These are two separate arrays, so anything that happens in erase_array will not impact value array. And I'll run the program. And you can see that when we print value array after the call to erase_array, we're seeing the values. The array was not erased. If I change that call to print copy and run the program again, you can see that copy is an array of zeros. If we print copy before we erase it, we can see copy is the values from the original array. Now, a built-in way to make a copy of an array of primitives, such as we have here, is to import java.util.arrays and use arrays.copyof. I'll comment out my copying code. To use this method, I'll declare the array again, int copy, and then instead of using new, I'll write equals arrays.copyof, and I pass in two parameters, the array I want to copy, so value array, and the length of the new array. I'll pass in value array.length, but I could use this parameter to make a truncated copy of the old array or to make a copy with extra space. In this case, the new locations would be filled with zeros. So this creates the new array for us and copies the old array into it, just as the manual copy did. It is important to know that this method works with primitives, but it might not work the way you want with objects. We'll talk about that more when we talk about arrays of objects in a future video. Okay, that's actually quite a lot. We looked at 3 different methods and how they were invoked. One method, readFile, returned an array. So that method created an array with the new keyword and returned it, and we assigned the return value into an array reference back where it was called. That array reference was never instantiated back in main because that would have resulted in an array in the heap that was never used. 2 other methods took arrays as parameters. One just printed the array, but the other changed the array. One of the trickier things to get used to with methods is the syntax of a return type or parameter that's an array. It's the data type of the elements in the array, followed by open and close square brackets. Any time you pass an array to a method, the method could potentially change the values in the array. If you don't want an array to be changed in a method, you can make a copy of the array and pass the copy. Remember that because arrays are objects, we do not copy them with an assignment statement. You can either create a new array, the same size as your array, and then loop through the original array and copy its values into the new array, or you can use a built-in method such as arrays.copyOf. It's important to remember that this will work well with arrays of primitive types, but may not work as you wish with arrays of objects. I hope you found this video interesting and helpful. There should be a lot here that's familiar. You just need to get used to putting it together with arrays. As usual, I've included an auto-graded exercise in the description of this video so you can practice with the video code. And the video code is available in my GitHub repository. There's a link in the description. As always, have fun and keep coding.